In this episode, we're moving from individual safety habits into a team-based safety practice that helps prevent accidents before anyone gets close to a hazard. A job safety analysis, JSA, is a structured way to look at a task, break it into meaningful steps, identify what could go wrong at each step, and decide what controls will keep people safe. In OT environments, tasks often happen near live processes, heavy equipment, and systems that can start or move in ways that surprise people. So the difference between a safe day and a bad day is often whether the team slowed down long enough to think. A beginner might assume that safety planning is only for major repairs or big construction work. But in OT, even small tasks can have big consequences if they involve cabinets, panels, energized systems, elevated areas, confined spaces, or moving machinery. A JSA is not a form you fill out to satisfy a rule. It is a shared conversation that creates a single, clear understanding of what will happen and how risk will be managed. When done well, it reduces confusion, prevents shortcuts, and gives everyone permission to pause if something feels off. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. The first thing to understand is what makes AJSA different from general safety awareness. Safety awareness is knowing that hazards exist, like high voltage or pinch points, while AJSA is applying that awareness to a specific job that will happen at a specific time with specific people. It is practical, not abstract, and it focuses on the task as it will actually be performed, not as it is described in an ideal procedure. In OT, that realism matters because work rarely happens in perfect conditions, and small details like cramped access, poor lighting, nearby traffic, or a noisy environment can change the risk dramatically. AJSA also forces the team to notice the difference between normal operating conditions and the temporary conditions created by maintenance, troubleshooting, or inspection work. Temporary conditions are often the most dangerous because people are outside their usual routines and may be improvising. For a new learner, the key lesson is that planning is a control, not an extra, because it shapes the choices people make once the work begins. If the plan is vague, people will fill gaps with assumptions, and assumptions are where incidents hide. A typical JSA starts by defining the scope of the job in plain language so everyone agrees on what is actually being attempted. This includes clarifying what equipment is involved, what area the work will occur in, what the goal is, and what done looks like. In OT environments, it is common for people to talk past each other because different roles use different terms or focus on different parts of the system. An operator might think in terms of process impact, a maintenance technician might think in terms of mechanical access, and a security learner might think in terms of device location or network connections. The JSA aligns those viewpoints by making the task explicit and shared. It also sets boundaries, like what is out of scope, which reduces the temptation to add quick extra work that was not evaluated for risk. That matters because unplanned add-ons often bypass controls, especially when people feel pressure to finish fast. A good scope statement is a safety control because it limits surprises. After the scope is clear, the job is broken into steps that are meaningful enough to expose hazards, but not so detailed that the analysis becomes unreadable. A beginner might think a step should be tiny, like turn a screw, but the goal is to identify hazard changes, and hazard changes usually happen when the activity changes. For example, moving from approach the panel to open the panel is a change, because opening a panel can expose energized components or create a pinch hazard. Moving from inspect wiring to disconnect a component is a change, because disconnecting can create stored energy release, sudden movement, or unexpected state changes. In OT, steps often include coordination actions like communicating with operations, confirming process state, establishing barriers, and verifying isolation, because those are critical moments where things can go wrong. When steps are defined well, people can picture the flow of work and notice where the risk spikes. That picture is powerful because it turns safety from a vague concern into a sequence of decisions. It also makes it easier for anyone on the team to say, "This step is where I feel unsure," which is exactly the kind of early warning you want. Hazard identification is the heart of the JSA, and it works best when the team thinks broadly about the kinds of harm that could occur. Physical hazards include moving parts, falling objects, slips and trips, and vehicle traffic, but OT tasks also involve electrical hazards, pressure hazards, thermal hazards, and chemical hazards. There are also hazards created by the environment, such as poor ventilation, high noise, or crowded workspaces. Beyond physical hazards, there are human factor hazards, like fatigue, distraction, unclear roles, or communication breakdowns, which can be just as dangerous because they lead to mistakes. In OT, a major hazard category is unexpected energization or unexpected movement, because a system may start due to automation logic, remote control, or stored energy. Another category is process upset, where a change affects operations and creates unsafe conditions like overpressure, overheating, or release of material. Even if you are not operating the process, your task can still influence it, and the JSA should treat that influence seriously. Identifying hazards is not about fear, it is about clarity, because you cannot control what you refuse to name. Once hazards are identified, the team selects controls, and this is where OT safety thinking becomes very practical. A control is anything that reduces risk by removing the hazard, reducing exposure, or reducing the severity of harm. Controls often start with physical protections, like guards, barriers, or isolation, because physical protections do not rely on perfect human behavior. Administrative controls include procedures, permits, briefings, and clear role assignments, which guide behavior and reduce confusion. PPE is also a control, but it is usually treated as a later layer because it does not stop the hazard. It only reduces harm if exposure happens. In OT environments, energy control through lockout/tagout (LOTO) is a major control for many tasks because it prevents unexpected movement and energization. Another important control is establishing an exclusion zone, such as using cones, tape, or signage to keep non-involved people out of the area. Communication controls are also critical, like agreeing on hand signals in loud areas or defining who has authority to call a stop. The best JSA controls are specific, realistic, and matched to the hazards identified, not generic phrases that sound safe but do not change behavior. Briefings are the moment where the JSA becomes real for the people who will actually do the work. A briefing is not just reading a document. It is a shared conversation that ensures everyone understands the plan, the hazards, and the controls. In OT, briefings matter because teams can be mixed, including operators, electricians, mechanics, engineers, contractors, and sometimes security personnel who are not on site every day. Each person brings different assumptions, and the briefing is where assumptions get exposed and corrected. A good briefing includes confirmation that the scope is understood, the steps are clear, and the controls are in place before work begins. It also includes an explicit statement of stop authority, meaning anyone can pause the job if they notice a hazard, a control failure, or a change in conditions. Beginners sometimes fear speaking up, especially if they are new, but safety culture depends on lowering the cost of speaking up. The briefing should also cover what to do if something goes wrong, such as who to call and how to respond without creating more risk. When briefings are done well, they reduce surprises, and fewer surprises means fewer injuries. A key concept in briefings is role clarity, because confusion about roles creates gaps and overlaps that can both be dangerous. In OT work, you might have someone responsible for isolating energy, someone responsible for verifying isolation, someone performing the hands-on work, and someone acting as a spotter or safety watch. If those roles are not clear, people may assume someone else handled a critical step, and that assumption can lead to a serious incident. Role clarity also matters for communications with operations, because changes to equipment or network connections can affect process visibility and control. A security learner might be focused on inspecting a device, but an operator might be focused on keeping a process stable, and both need to know what the other is doing. The briefing is the place to align these perspectives so that actions are coordinated and predictable. If the task involves entering restricted areas or opening cabinets, role clarity includes who has permission and who is accountable for the area being safe. This is also where PP requirements should be confirmed, because different zones can have different rules, and guessing is not acceptable. Clarity is a control because it prevents silent failure. As work begins, one of the most important ideas is that AJSA is not a one-time event because conditions can change. OT sites are dynamic, with equipment starting and stopping, people moving through areas, weather affecting outdoor work, and operational priorities shifting. A strong team treats the JSA as a living agreement, meaning if something changes, you pause and reassess rather than pushing forward on autopilot. A common change is discovering that equipment is different than expected, like a panel layout not matching what someone assumed, or a valve not behaving as predicted. Another change is realizing that the work area has become more crowded or noisy, making communication harder. Changes can also come from process constraints, like needing to keep a line running longer than planned, which affects whether isolation can occur. The safe approach is to stop when the plan no longer matches reality, because continuing is essentially choosing to operate without controls you evaluated. For beginners, this is a major mindset lesson. Stopping is not failure. Stopping is competence in a hazardous environment. Outbriefs are often overlooked, but they are where teams close the loop and prevent the same problems from repeating. An outbrief is a short review after the work is complete, focusing on what went as expected, what surprised the team, and what should be improved next time. In OT environments, outbriefs are valuable because they capture lessons while they are fresh, and they help teams refine procedures and JSA templates based on real experience. An outbrief should confirm that the work area is safe, that tools and temporary barriers are removed appropriately, and that equipment is returned to the correct state under the correct authority. If locks and tags were used, the outbrief includes confirming that removal followed the rules and that verification occurred before returning equipment to service. It also includes confirming that any changes were communicated, because even small changes can affect future work or operations. Beginners often assume that finishing the task is the end, but in safety thinking, the end includes a clean handoff back to normal operations. A sloppy ending can create the next incident, especially if someone later assumes a system is in a different state than it really is. There is also an important link between JSA practices and incident prevention beyond safety injuries, including security incidents that arise from misunderstandings and uncontrolled changes. In OT, a security-related task can affect availability, visibility, and trust, even if it is not intended to. For example, if someone disconnects a device to inspect it without coordinating, operators may lose monitoring data, alarms may behave differently, or control logic may react to missing signals. That can cause a process upset, which becomes a safety risk and an operational risk. AJSA encourages coordination, which is also a security benefit because coordinated changes are less likely to create unknown states that attackers could exploit. The same discipline that prevents accidental harm also reduces the chance of accidental exposure, like leaving a cabinet open, leaving a port exposed, or bypassing a control without documenting it. Beginners should understand that in OT, safety and security share a common enemy: unmanaged complexity. AJSA is a tool for managing complexity by forcing the team to slow down, align, and control the work environment. A common misconception is that AJSA is only useful when the task is dangerous, but the truth is that AJSA is most valuable when the task looks simple. Simple tasks invite shortcuts because people feel confident, and shortcuts remove the layers that keep small mistakes from becoming big incidents. Another misconception is that the JSA is about predicting every possible problem, which is unrealistic, but the goal is to identify the most likely and most severe risks and control them. People also sometimes think AJSA is someone else's job, like a safety officer's job, but a good safety culture treats it as the team's responsibility. A beginner might worry that asking safety questions makes them look inexperienced, yet in OT, asking safety questions usually signals maturity. The site would rather have a cautious learner than a confident person who guesses. This is also why the briefing should invite questions explicitly, because silence does not mean agreement. It often means uncertainty. The real purpose of the JSA is to make safe behavior easier than unsafe behavior. To bring all of this together, a job safety analysis, JSA, is a practical method for making OT work predictable, coordinated, and controlled in environments where hazards can be hidden and consequences can be immediate. It starts with defining the scope so everyone shares the same understanding, then breaking the job into steps that reveal where risk changes. It identifies hazards broadly, including physical energy hazards and human communication hazards, and then selects controls that match those risks, using isolation, barriers, procedures, and PPE as needed. Briefings turn the plan into shared reality, with clear roles, clear communication, and clear permission to stop when conditions change. Outbriefs close the loop by confirming safe restoration and capturing lessons that make future work safer and smoother. For security OT plus success, the key is to see these practices not as paperwork, but as professional discipline in environments where the margin for error is small. When you carry that discipline into every OT task, you become safer, more trusted, and better prepared to answer exam questions that test judgment under constraints.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.